Hi, my name is Adam Dekich. Today's date is February 26, 2026, and this is my week 6 case study for Dr. Noble's Chem 1020. I will share my screen. I wanted to talk about the molecule PEA, which is polyetheramine. It's a fuel injector cleaner that I use when I'm working on my car. I've had a lot of success using this. I like it a lot, and I've always wondered how did it work. So that's why I picked that molecule. It's called polyetheramine. Its molecular formula is C21H46N2O6. The industrial name is Jeffamine 400. The IUPAC name is alpha 2-aminomethylethyl omega 2-aminomethylethoxy polyoxymethyl 1 2-ethanediol. It's quite the mouthful. I guess that's why they called it Jeffamine. That rolls off the tongue. Like I said, it's a fuel injector cleaner, and it cleans carbon deposits on the inside of an engine, like on the in the one on the fuel injectors, but also in the combustion chamber. And the way that it works, apparently, it's hydrophobic like oil, so that it can mix with gasoline, and then it works much like soap because part of the molecule will attach to the carbon deposits and the other part of the molecule will attach to the fuel and oil and then the carbon gets washed away, which I thought was super interesting. And another note about it is that it's very thermally stable because it needs to operate inside the engine while the engine is running. As far as connectivity goes, it's called an oligomer. It's not a polymer, it's called an oligomer since it's made of more simple repeating units. And you can see here I've highlighted that repeating unit, which is the little methyl group and the ether, and there's six of them. And then you can see here I've labeled the substituents. So it's got the amines on either end, and then in the middle it's the methyl groups and the ethers. As for chirality, I have used the wedges here. I made them all coming out of the page, and it's obviously got seven chiral centers, which gives it 128 stereoisomers. So that's another reason that it cleans so well is because it can take many different conformations and it's got many different stereoisomers all mixed together. And so it works very well to attach to the irregular surfaces of all these carbon deposits inside the car engines. And here I've labeled the chiral centers using the Kahn-Ingold prelog system. So for this first one, using the atomic weights, we have nitrogen as the largest, and then next is the carbon that attaches to the oxygen, and then the third is the carbon that attaches to the hydrogen. So this is an R, but it also has, in this particular stereoisomer, it's got R, S, R, S, R, S, R. And then, like I said, it's got 128 stereoisomers. And then I used MoleView website to put together this little model of the molecule. And it's actually turned out quite nicely, I think. So glad I finally figured out how this stuff works because I like it a lot.